Yeah, hello everyone. My name is Chen Yuhan from Huawei Wireless Marketing. Now today, my topic is Win the Future with LTE TDD. And firstly, I will give the industry insight. Yeah, LTE TDD is worldwide commercial application. Now there are 36 commercial networks already. Yeah, and 11 million subscribers all over the world. And including the Asia Pacific and the North America and the Europe. And most famous operators use TDD network, already roll out the TDD network. For example, we know that in China, the China Mobile, roll out the biggest TDD network. Now, in the end of this year, about 500,000 ELOB, maybe the biggest network. And the soft mobile is 50,000 ELOB. And the smart, this is the biggest 3.5 gigahertz network, TDD network. And for the Optus is the first GSM, UNTS, TDD, FDD, convergent network. Yeah, and TDD developed with the strong industry partners. Now, including more than 100 operators, and supported by the GSMA and GTI. And the chipset and the device can support the multi-mode and multi-band. I think the expert said, the MSM expert said he get the mobile phone from China, can support 5 mode, 12 band. Actually now, the China Mobile requests the device vendor provide 5 mode, 19 band. Yeah, 19 band, more than 12. Yeah. Now, in the end of last year, the China Mobile launched LTE TDD network. It's the biggest network, 500,000 ELOB, and covered main cities already in China. And followed by the China Telecom and China Unicom. But compared with China Mobile, the BTS, less BTS. For China Telecom and Unicom, about 60,000 BTS. And let's consider because this is the end-to-end solution for LTE TDD. The device is very important. So let's see the device. There are more than this number update, more than 400 times of LTE TDD device, and more than 100 of them are smartphone. Yeah, now we know the iPhone support TDD already. And for the handset, now this is the China Mobile's handset. China Mobile requests the device vendor provide the 5 mode, 19 bands, and this is 19 bands. So worldwide roaming with one device. Worldwide roaming is not the problem. And compare with FDD, now I can say a word, the equal. And LTE TDD equal to FDD now, from 4 perspectives. From technology perspective, almost based on 3GPP. more than 90% spec the same. And from frequency perspective, yeah, the high band, middle band, and the low band, TDD have and the same as the FDD. And for the ecosystem, yeah, we know the device, main device vendor support FDD and TDD. And for the BTS shipment, compare with FDD and TDD, because China Mobile, you know, the 500,000. So BTS number almost the same. And now the FDD and TDD conversion is the trend for one LTE. Yeah. Now there are 13 commercial level, and we from the estimation in the end of this year, 50 can support. Then for the one LTE, two key technology. One is the aggregation, FDD and TDD aggregation, and one is synergy. Yeah. For example, in the hotspot, we use the TDD to absorb the traffic. But if the TDD use the high band, the coverage is smaller than FDD. So the synergy, the handover, the reselection, we should consider. I think this is complete solution for synergy between the FDD and TDD. And then for the TDD industry, we focus in the end of this year. Global TDD contract will be 130, and BTS shipment over 700,000, and TDD device more than 1,000, and subscriber, yeah, 130 million. And this is a huge leap again, because last year is huge leap because of the trailer operator, and this year again, because the plan for China Mobile last year is 250,000 BTS. This year, double, 500,000. So it's the huge leap. And then we want to know the LTE TDD's performance. And LTE TDD can inspire the best experience. Because the LTE TDD can provide the fastest speed. Yeah. Compare with FDD, if we used 10 megahertz for TDD and use 10 megahertz for FDD, because uplink and downlink, so equal to 5 megahertz for FDD, we compare. Then we can see LTE TDD is better. Because we can uplink and downlink, we use the 3-to-1, yeah, not even, yeah. Downlink will give the higher bit rate. So LTE TDD, the performance will be better. So for the hotspot, if TDD use the high band, so we can use TDD to absorb the traffic. And the latency, LTE will be better compared with 3G and GSM, yeah. And we know the difference between FDD and TDD is the TDD uplink and downlink, we can flexible, yeah, flex setting. And this is a statistic, yeah, from the commercial level. Then we find, compare the downlink traffic and the uplink traffic, about 6-to-1, downlink to uplink. Actually, we use, most commercial level use 3-to-1. Some commercial level use 2-to-2, yeah. Then if we use 6-to-1, the downlink will be more bit rate. And as we know, the voice and the video will be the main service for LTE. Yeah, for the voice, for the CS4 band, yeah, we use CS4 band. Then for the release line, the delay will be shorter. And if we use VoLTE, 1 second. And we can use the solution, voice quality solution, compare with the GSM and the narrow band AMR. We use wide band AMR for VoLTE. Then the most larger than 4. And the CA and the COM is to keep technology for LTE. And now the TDD interband and intraband CA commercial already. For example, we use 220 megahertz, yeah, and downlink to uplink is 3 to 1. Use the carrier aggregation, we can reach 220 megabit per second. And this is a TDD and FDD CA. TDD and FDD CA. This CA, if we use 20 meg for FDD and 20 meg for TDD, because this multiplied by 2, uplink and downlink, then we can get 260 megabit per second. This is the CA's case. In Australia, 2cc component, and they use the 2.3 gig, and we can get the 220. And China, yeah, over 200. Then we did the test or the trial in the Barcelona with Vodafone. We use FDD and TDD CA. We can reach 500 megabit per second. For this CA is 3 FDD carrier, 2 megahertz and 110 hertz, and TDD. And LTE CA, yeah, LTE TDD CA chipset. Now we can see it. In the end of this year, yeah, the chipset can support. And we forecast next year, Q2, the device can support, most device can support the TDD and FDD CA. Next year, Q2. And for the COM, DL COM can enhance ad user's experience. Yeah, because this UE, this neighboring cell, he can send the information both paths and combine in this cluster. So the user experience will be improved. And this downlink, if there are interference from this cell, we can mute this cell. Then the interference will be reduced. Yeah. And this is the interference mitigation. And this uplink COM. Yeah, the UE can send both information to the cluster. Yeah, then combine. Will improve the uplink user experience. And for this case, because this UE's singular will interference this UE, yeah. Then, because this UE send the information to this side, this information will send to this eLoB. He will load this information, then he will cancel this information in this path. Yeah. So interference will be reduced. Now I introduce the LTE performance. Then we come to the LTE TDD business model. Firstly, we should consider the cost, the TDD spectrum's cost, compare with FDD. Yeah, from this operator, statistic from this operator, we know about 20% cost for this spectrum compared with FDD. And for the TDD spectrum, yeah, you can say more than 50%, top 200 operators have TDD spectrum. Yeah. And for example, the Australia Optus, they have the 2.3, and for the softband, and they have the 2.6. For the China Mobile, have the 2.6. So this operator need the conversion of FDD and TDD. And now some operator use TDD not as the MBB network. Some operator use as the WBB. Yeah. For example, in Philippines Smart, yeah, because there are many islands. If they use fixed level, use fiber, the cost will be higher. Then they use the TDD network as the WBB and provide the fixed network experience. Yeah, and this is the WBB. And this is the eMBMS. Yeah, because the if we have the initial the video, often unicast. If many person see the same video, then the resource, the cell will be congested. So we use the eMBMS broadcasting the same content. Then you can send many channels. We already commercial in China. Commercial in China. You know, now is the World Cup, football World Cup. Then the operator, there are four channels for World Cup. And the end user should pay the money. Then they can access this channel and see the football cup, World Cup. And this application is LTE in car. We use this window and access LTE TDD network. Yeah. Then in the car we can showing the web browsing, see the video. Yeah. This is the bus, used in bus. Yeah. Then the customer can see the video in the bus. And we used LTE and Wi-Fi solution. Because if the user access AC, we cannot charge the user. So we can, in the CPE, we can set the password. The user only access the EPC, and the EPC connect to AC. Yes, this is the VPN. Then we can charge the channel speed. The traffic, yeah, through this channel can be charged. And this is enterprise communication over LTE TDD. Then we set the VPN and the LTE network as the VPN tunnel. Then all the traffic through this tunnel will be charged. And this is enterprise application. Finally, I want to summary. And LTE TDD is a fast track, and TDD and FDD equal in 4 perspectives. And the TDD can provide much higher throughput and low latency. And LTE Advanced aim at super faster and low edge experience. And there are many new LTE features and service: WBB, eMBMS, LTE and Wi-Fi, and VPN. Yeah. So I think it will attract end user and operator.